Hi everyone, thank you for coming. Last week we spoke about digital signature, right? Not digital signature, today we're going to talk about digital signature. We spoke about hashing, right? Last week we spoke about hashing. So when you have a message, we'll create a hash, we'll have a hash function for example, all right? And we'll give you what? Digest, we'll give you the digest, all right? So usually the message could have a variable, length, right? But the digest usually is a fixed length, right? Okay, and we looked at some of the hash functions, like SHA-5, I think, 512 last time, all right? And there's many different kind of hashing function, right? Right, and for the hash function, it has to have certain characteristics, like first pre-image, second pre-image, and collision resistance, right? Three characteristics that any hash function have to have, right? So today we'll talk only about digital signature, which will be kind of a short lecture today, and then after that we'll talk about your research project for this semester. All right? Any questions? All right. Digital signature. All of you sign papers, right? You sign papers. Usually when when you go to your bank or you have a contractor, you sign. So the signature, your signature is a proof that it's you who executed this document. When you sign a check, you send it to the bank. The bank will compare your signature on the check with their files. All right. With their files that it's the same signature. So now we are in the era of the digital signature, where, when you send a document, you need to sign it, that you are the person who executed it, right? All right? And unlike like the paper signature, the signature has to be in the same paper. In here now, the signature and the document could be different files. Okay, it could be sent differently, different times. Okay, and then the receiver will be able to verify that you are the sender by checking the signature. So that's what is digital signature. All right, it's used a lot in real life right now. Maybe later we're gonna learn about the certificates, or if you have certificates, but that's what you use for. Okay. All right. So here, okay. So in the conventional signature is included in the document. As I said, it is part of the document. So it's part of the document. But when you sign a document digitally, we send the signature in a separate document. All right. So I don't want to compare too much. Who cares about the regular signature? You know it, you loved it, and you use it a lot. So what we care about is the real signature or the process. All right. So what will happen in here? You have in here a message that you need to sign it. Okay, message. So basically, you'll have a signing algorithm. Okay, signing algorithm. You'll sign it, and then you're gonna send a message. Sorry. The message and the signature separately. I'm sorry. So when the document and the signature goes to the BOB, the recipient will be able to verify using a verifying algorithm that you have signed this document. All right. So basically, how is it done? How is it usually done? It's done with asymmetric encryption, with public key encryption. That means you have two keys, public and private. Remember in chapter 10, if I remember correctly, that we use the public key encryption. Use it for what? To encrypt data, right? So you have a sender and receiver. There is public key and there is private key. So the sender used what to encrypt?
Public.
The public key, right? And of who? Of the private guy, right? This is needs a. So you have a sender, and you have a receiver, sender and receiver. So the sender will have a public key, public, and public, PU, okay, and private, PR, we say. And the receiver will have public key, which is PU, and a private key, right? All right. So when you need to send a message, the message needs to be sent, okay? It will be encrypted using what?
Public key.
Public key of who?
From sender.
Receiver.
The receiver. So using the public key of the receiver or public. All right. When the message is encrypted with the public key of the receiver, who is the only one can open it or read it? The receiver using his
Private
private
key.
key. All right. So the data is encrypted. Okay. So the sender has to know the public key of the recipient. Where he get it from? Published in his web page, right? Or somewhere. Okay. Then he use it, and the only one can read the message is the recipient using
Private
the
key.
private key. It's like a private key. And here we do the reverse. Here we have to sign. We don't have to encrypt the data. So what we do, okay? So you have the signing algorithm. There is a public and a private key. So Alice private key. We use Alice private key. Alice is the sender. So Alice knows her private key and knows her public key. So she will use her private key to sign. All right? And it will be transmitted to the recipient, to Bob. Bob now needs to verify that Alice sent the message. So how she does that? Using the public key of Alice. All right? Public key of Alice. So digital signature needs a public key system. You have to have a public key system. The signer signs with her private key. The verifier verifies with the signer's public key. Very simple. All right. So a crypto system uses the private and public keys of the receiver. A digital signature uses a private and public keys of the sender. All right. So it would be wise if I need to have like encrypted message and signed message to use both together. So I could encrypt it using the recipient keys, and I could also sign it with the sender private key at the same time. So it will be encrypted and signed. So signing the, okay, so the problem now, if you remember that, the message, what is the major deficiency? Deficiency is a good word. Okay. What is the main drawback of public cryptography?
You used to have only one key.
Public has two keys, right? Am I confused? Which one it uses two keys? The asymmetric. Right. Okay. All right. What is it's a problem. That's what we call public cryptography, right? What is a major deficiency? What is a major problem with it?
Size.
Size? Size of what?
Message.
Okay, what's the problem with it?
It's limited to 128.
No, I mean you could have any size of a message, but it becomes very slow.
So
It's very slow, right? I mean, the more the size, the bigger the message. I think since I entered this room, it's cold. I start feeling sick now. So I mean, I mean, because it's like exponential operation, if you remember, mostly, so it will be very slow. So we don't recommend it to encrypt the whole hard disk drive and all of that. We could use it for different applications. So we're talking about a message. If we need to use a private key to encrypt it of the sender, all right, or public key of the receiver, doesn't make a difference. It will be very slow, right? So what I'm trying to do in here is just to verify that it's the person, right? So the simple thing to do is to create a digest of the message, and that will make it what? Small. And then assign what? The digest, not the whole message. Okay? So creating the digest is like SHA-512 is a very fast. Creating a digest is easy. Remember that in the hash functions, the input could be variable, it could be a very long message, and the output only fixed size, like 512 or 256 or 128 or whatever, right? So instead of signing the whole message, I don't need to sign the whole message. I create the digest and I sign what? The digest. When I sign the signature with the message, the recipient, what does it have to do? Generate the digest again and check if the signature matches. Clear? So we don't have to sign the whole message. We don't have to sign. We sign a digest out of it. We pass it to the hash function, right? So, all right. So that's what we did in here. So that's my message in here. All right. I don't have to sign the whole message. I'll take the digest. And remember what kind of hash function we have? It's one-way hash function. One-way hash function. What does it mean? That every message will have technically what? One digest. One digest. And then we sign the digest. Alice signs the digest with her private key, and you're gonna send the message with the signature. So what you do first, you verify the signature. You receive the message. All right. You create the hash again, and you and you check the. And then you verify the hash, the hash signature from both sides. If they are the same, then it's correct signature. If they are different, then it's not a correct signature. So that's what a way to speed up the process. All right. So what are surfaces we are providing? Remember in the very first lecture, we said there's mechanisms and surfaces that we are always trying to provide. So what surfaces we could have? Confidentiality, it's a surface, and authentication is another surface. Message integrity is a third surface. All right. How about confidentiality? Does digital signature provide confidentiality? No, it does not provide confidential. Does it provide authentication? Yes, authenticate the sender. Does it provide a message integrity? Yes, because that's the whole job of hashing. When you create a hash of a message, okay, that's what we did last week. We're trying to check the integrity of the message. How about non-repudiation? Yes. So it could provide 3 out of 4 services. 3 out of, okay. So a secure digital signature scheme, like a secure conventional signature, can provide message authentication. Right? Why is it message authentication? Who gonna sign it? The sender, with her private key. Nobody can fake the private key. Okay, so we know when we receive it, we use a public key with that person, then it's authenticated. So very simple, we could use it for authentication. Okay, the integrity of the message. The integrity of the message is preserved even if we sign the whole message, because we cannot get the same signature if the message is changed. Any change in the message, you will not get the same signature. So definitely with the signature you maintain the integrity of the message. Repudiation, okay, this is like a tough cookie because you know the recipient or the sender could deny sending or receiving the message. So the sender, so basically we have to have a third party, okay, to have a third party to, you know, guarantee that, so for example, Alice could send the message, sign it, then after a while it changes her private public key pair and she denies it, did not send the message. So by itself, it cannot. So the way you do it is you have like a third center. So what will happen? That Alice will all right. So Alice will sign with her private key. So it will be signed, and the message does not go directly to the sender, to the recipient. It goes to a middle center. So it will receive it in the middle center, or we call it a trusted sender. Trusted by who? By everyone, by the senders and receivers. All right. Like when you're doing business, when you communicate, there is a center that could sign the documents for you. All right. So Alice uses the public key to verify the algorithm. So the third party used the Alice public key to verify the message, and then sign it again with the center's private key. And this center is trusted by everyone, right? And then it will be sent to Bob. Who signed it to Bob? The third party, the trusted sender. All right. So now, once Bob receives it, and once Alice sends it before, none of them can deny that they did not send it and receive it. All right? None of them, yes.
So if Alice publishes her public key,
Yes.
and I have a record that she published it,
Sure.
and I can decipher her signature, isn't that proof that she sent it? Isn't that proof enough? It came to the repudiation intent?
Well, I mean, you and I could have our public key, and we could revoke it. Okay, we could revoke it. Okay, and when you publish your public key, you could publish your public key in your page. That's what it is. So myself, if I need people to communicate with me securely, I could publish my public key in my web page. All right. And then yourself would like to send a private message to me, or you would like, for example, to sign a signed document. What are you gonna use? You're gonna use, my public. Okay, or myself, I could use my public or private, right? But this I could revoke them at any time.
If I get an email from you saying this is my public key,
Well,
I keep that as record.
it's a different story, right?
Uh-huh.
There's a different
This-
story, right?
this has to
Yeah,
be-
but anytime I could deny it. Okay, well, how about if I did not? If you tell me that, what if somebody use my email, or somebody send you from a fake email, or I changed? I tell you no, that was before. I changed my pair like 6 months ago. So always there is no 100% cut proof that you use or I used my keys, right? How is the business done now? There is a third trusted party, and that's where we get the certificates. Right? Next chapter we'll talk about it. Okay, certificates. Now, for example, like when you download the certificate, how the certificate is created, trusted by a third party. That's why they call it certificate. All right, that's how it is. Yeah. So did I answer your question?
Yes.
You convinced? All right. So that's what happens. Okay, that's how it happens, right? So non-repudiation can be provided using trusted party. Right. All right. So these are the services. So 3 out of 4 services that easily we could. How about confidentiality? We have to have encryption for confidentiality. So that's what we do exactly. So we have the message. What we do, we sign it with Alice's private key, but also we do encryption using the Bob's public key. So we do signature with the sender's private key, and we do encryption with the public, with Bob's or the recipient public key. So this way, we guarantee that we have the data, the four services, the confidentiality and the recipient. All right. So now it does not need to have. By the way, the encryption does not need to be like public encryption. So you could also have private key. If both of them share one key, you could encrypt with the shared key. Okay. However, for signature, we have to use asymmetric keys, two keys, public and private. So you could do either way, right? The digital signature does not provide a privacy. If there is a need for privacy, another layer of encryption must be applied. Very simple, very simple. So the question is, does encryption by itself work like a signature? The answer is no. Because anybody could use my public key, right? We use the public key of the recipient. So anybody could use a public key and claim it's anybody, right? Right. So definitely we need to have the signature. All right. So attacks on digital signatures. There is, there's attacks and forgery types. Okay. So what kind of attacks we could have? We could have key. Remember also from the second chapter we covered there is different kind of attacks. And this different kind of attack depends on what? The information you have. So if you have a key only, or you have a key and a message, or two keys and two messages, so that will change the strength of your attack. The more information you could have, okay. So you could have key only attack when you have a key, or you have known message attack. You know a message with a key you could attack, and you have chosen message attack. So these are different attack: key only attack, known message attack, and chosen message attack. So in the key only attack, the Eve is the evil. Eve is the evil. Remember, E with the E is the evil. Okay. Has access only to the public information released by Alice. So to forge a message, Eve needs to create Alice's signature to convince Bob that the message is coming from Alice. All right. And this is similar to something we explained before, which is the ciphertext only attack. Yeah, only ciphertext attack. Okay, which is very weak attack in this scenario. The second one is the known. The second one is the known message. In the known message, so Eve, the evil, has access to one or more message signature pairs. Message and signature pairs. And from there, you try to use it, okay, to send a message or forge, a signature to Bob. All right. And this is similar to non-plain text attack. Non-plain text attack. The third one is chosen message attack. Chosen message attack. And here we know more. So Eve somehow makes Alice sign some messages for her. So, to contact Alice, the sender, and sign some messages. So now the evil or Eve knows what? The signed message and knows the public key of Alice. So try to do something with it. And this is similar to the chosen plain text attacks. All right. Also, in terms of forgery types, okay, there's two forgery types could happen. The first one is existential forgery, where Eve may be able to create a valid message signature pair, but not one of that she can really use. So it's again, it's like a weak forgery attack. And the other one is selective forgery, which is also a very negligible attack. So basically, you know, with the traditional ways, it's a very hard. All right. So now we come to the next section. I'll cover only the one part of this section. Is what is bread and butter to create a signature? What is the tool? What should we have?
Hash.
Hash one thing, but the main thing is a public key cryptography, like RSA. We covered many of them in chapter 10, right? Because you have to have a public key and private key. So if you look at your textbook, okay, the first thing they explain, for example, okay, how to do it using RSA digital. That's what we'll cover today only. I leave this for you to the RSA digital signatures key. What is RSA? It's a public cryptography algorithm, right? Then number 2 in here, they use Al-Jamal digital signatures key. What is Al-Jamal? A public key cryptography technique, right? Where you have 2 keys. Then you could use Schnorr digital signature scheme. What is a Schnorr digital scheme? The same thing. It is a public key cryptography technique. I think it was explained in chapter 10. Then what you could use, you could digital signature standard, DSS. It's again, it's like creating 2 keys, public and private. All right.
Close.
Then 5. Hello. 5. So elliptic curve digital signature scheme. This was covered in chapter 10. What does it do? Public key cryptography. So it could go another 15 different algorithms. You could apply digital signature, right? As long as you have algorithm you're gonna use, which generates 2 keys for you, public and private. Okay? So that's your bid and butter to create a signature. You have to have a public key. Okay? So let's take a look as an example at the first one, okay, which is the most common, the most famous, I'm sure all of you have heard it, okay, which is the RSA digital signature. All right? So in here, for example, yes, they use like 50, okay. So now, the question is, why I would use, for example, RSA? Why not, for example, Al-Jamal? Why not Schnorr? Why not DSS? Why not elliptic curve? All right? What is the difference between these? Is there any difference? I'm just asking, I want to wake you up, that's all. I mean, just
Just a function underneath it.
okay. So they are different. They're different in their security level, security, in the key size, in the speed, in the performance, right? So, for example, the last one, elliptic curve, digital, is the most lighter one. So light, okay, but maybe it's less secure, maybe it's more secure. I forgot right now. All right. So there's many. The question is, why we have so many algorithms? Because they perform differently. They have different key size. They could be secure for certain data more than the others. So you'll find some algorithm, for example, is very secure when it encrypts plain text. But you know, you find another one is much more secure for binary data, for example, digital, like video. Right? So the performances are different. The performances. sometimes is different than all of it. Anyways, for our topic today, we are talking about digital signature. We could use any of these, and maybe another 15 not mentioned in here that you could use. As long as you have an algorithm that use public key cryptography. What public key cryptography is? Asymmetric cryptography. What is asymmetric cryptography? It is a cryptography that has two keys, which is public and private. That's it. So let's take our first one, RSA, and help me, because you already done that, the RSA. So in RSA, what we're gonna do, there is a public key and the private key. Anybody remembers what was the public key?
Sure. It's
The RSA. You just came, man. It's very hard to know the question right away.
What was that, N?
E and N, you remember, right? And D, it was the private key, if I remember, right? Okay, something. So there is like equations. We create the phi, and then from the phi we calculate E, and D is the inverse. All right, if you remember, right? Okay. So there is a public key and a private key. All right. So when you look at here the message and the signature. So we have to. Okay. What is the private key? Is EN, right? So we sign the message with EN. E and N are the private key of the sender, okay? And EN is, I'm sorry, the public key of the sender. Is it the public or the private? EN is the
Public.
private key. EN, this is wrong, by the way. Cannot be wrong. EN is the because what we do, we in digital signature, what we use, the private or the public key? Private. So EN is what? EN is the private. This is wrong. Must be wrong. The EN is the private key. Here is the private key. All right. We create a signature. We send the signature, and what we're gonna use at the destination? We're gonna use the D and N. Okay. To D and N to find the signature. All right. So, if you remember, if you remember that what Alice has to do, Alice is the sender, right? So Alice first has to pick two primes, if you remember, P and Q, right? And then calculates the N. What is N? P times Q, if you remember, N times Q, right? And then after that has to calculate the phi N. What is a phi N? P minus 1 times Q minus 1. Then from there it has to choose an E. Then the public exponent, and then calculates the D. The private exponents such as E times D equals to mod phi N. I mean, this is in chapter 10 how it works, right? Okay, and you're gonna have your second exam in a couple of weeks. So if you don't remember, you need to start to remember. Okay? Alright, so because you have the exam in 2 weeks. Alright? Okay. So Alice will keep the D, okay? And she publicly announces the N and E. So N and E are the public keys, and D is the private key. Alright. So basically in here we are not giving you no news. It's just explaining RSA. RSA, where you generate the keys. Okay, so that's what will happen. Okay, RSA digital signature scheme. So Alice will sign the message, right, using the Alice's private key, which happen to be a D and the N. Okay, so it takes the message to the power D mod N or modulo N. In here, modulo N will send it. And it could also encrypt the message, not necessarily, it could. And then at the recipient, what will happen? They will decrypt the message, all right, using EN. E is a public key, the private key, and then compare the received message with the calculated message. If they are the same, then accept the message because it's the right signature. If they are different, then it's not the correct signature. So in this in this figure, there's two things missing to improve it, right? The first thing, instead of signing the whole message, we could sign the digest. It would be faster. And also, we could add to it the encryption, whether it's public or private encryption. It will be very strong. So if you can sign the digest, will make it faster. If you include the encryption, will make it confidential, authentication, non-repudiation. Non-repudiation not achieved. Also, we have to have a third party, party, third trust party. All right. So you could make it very secure, signed, perfect system. All of this will add to what? To the complexity. Will add to the complexity. All right. So this is example. Maybe you remember this from chapter 10. So for example, trivial example. Okay, Alice. What will do? Alice will pick P, which is a prime number, and the Q, which is another prime number. Now we have P, Q. Now calculates N. What's N? You multiply them together. You're gonna have the N. Multiply them together. All right. And then we calculate phi N. What is phi N? P minus 1 times Q minus 1 will give you this number. Now she chooses this number, E, and calculates D, which is this number. Okay, what's E? The public key, right? And D is the private key. At this point, key generation is complete. Now imagine that Alice wants to send a message with the value here. That's the message. 19070. All right? All right. So to Bob, she uses her private exponent. What's a private exponent? D. Okay, to sign the message. So this is the message. The signature is the message, which is 19070, exponent to whatever this number, mod the N, and we'll give you this results in here. So that's that's the signature. And the recipient, you're gonna take the signature, put it in here, then use the public key, mod the same N, and we'll give you here. What is this in here? The original message. Bob accepts the message because has verified Alice's signature. So you could use any, it's not necessarily RSA, you're gonna use one algorithm that uses public and private key. Oh, that's what I was talking about, so good you mentioned that. So the best thing is to use it on digest, because it will be smaller size, it will be faster. So instead of signing the whole message, we sign what? And that's, by the way, the real life like this. I mean, we never sign the whole message. We sign the digest. We create the digest, which is very quick algorithm. Okay, you sign it and you send the signature on the digest. All right. So you create the message. You create the digest using the hash function, and then you sign the digest. You send the digest, and at the destination you do the reverse thing. So you check the digest. If the digest is equal to the digest, then it's the accept the message. Right? So when the digest is signed instead of the message itself, the susceptibility of the RSA digital signature scheme depends on the strength of the hash algorithm. The stronger the hash algorithm, the better. So in here, then the book explains the other 4 algorithms. I'll leave it for you. In terms of this chapter talks about digital signature. Now you got the idea. So now in here, Al-Jamal, they get explain Al-Jamal, which we covered in chapter 10. Okay, you explain again how to generate the keys. We already explained it in chapter 10. All right, and they give you example. Then they're gonna talk about which one is this. Then you have the Schnorr digital. So how you generate the 2 keys, and then how to use it. The same thing. Okay. Then after that, you're gonna talk about the different, DSS and then after that, they'll talk about DSS versus RSA. So computation of DSS signature is faster than computation of RSA signature when using the CMP. And then comparing between the different algorithms. Anyways, the idea of today's lecture is to understand how digital signatures work. How digital signature work. Alright, let me repeat it one more time. Alright, digital signature is a technique to sign a message digitally. You could send the message and the signature in a separate file. Alright? It depends very much on the public key cryptography. You could use any public key cryptography. Maybe the most common one to our brain, usually the RSA. Alright, where you have a private key and public key. So then what you have to do with the message first, you have to create the digest. How many techniques for digest to create the hash functions? How many hash functions we have? We covered that last week. There's tens of algorithms. Alright, tens of algorithms. What make a hash function strong? The longer the key, right? The longer the
Key.
the digest. The longer the digest. From last week also we have learned that there is two types almost of hash functions. Anybody remembers? With key and without key. We did not attend last week. With key and without key. With key is like using a private key. Okay, it will be much more stronger. But with key, without key. So in here, let's assume that we're using without key, right? So you're gonna take the message, you're gonna create the digest using a one-way hash function. So the digest now I have to encrypt it using
Public key.
private key of the sender. Private key of the sender, right? And this will be sent to where? To a third party. To the third party. Alright? The signature will be sent to the third party. The third party will check the signature of the issuer. If it's correct, what does it do? Sign it again using their private key. We'll send it to where? To the recipient. What does the recipient do? Check the signature of the third party. If it's correct, then we'll accept the message. Coming from where? Alice. Bob will accept it from Alice. So this, what we have sent through this process? The signature. The signature. Alright, if I need to have a confidentiality also, what I do with the message? I encrypt it using either public cryptography or symmetric or asymmetric cryptography. If it's asymmetric, how many keys I have? 2 keys. Which one I gonna use for cryptography? The public key of the recipient. The recipient. So I encrypt it with the public key of the recipient. We'll send it to where? Directly. We don't have to have a third party. Send it where? Could be to where? To the recipient. The recipient what do? Will decrypt it using its own private key. So we guarantee the 4 surfaces. Very simple. 4 surfaces. Right? Very simple. Very simple. All right. This is just a way to use the tool you have, which is the public key and private key encryptography. All right. Where is the real trick, the real design? Where is it? On those algorithms. The RSA, the Al-Jamal, all of these. The stronger, okay, and also how strong also the hash function. Right? Okay. Does that mean it's a very secure? No. I mean, any algorithm will have weakness and a problem that he could, do, right? So variations and applications. So there is different applications and okay. So all right. Now time is coming. We could also, sometimes a signed document need to be timestamped to prevent it from being replayed. Okay, you could receive a signature. Somebody could receive and send it later. Okay, later, as if it's coming from of that person, but it's not. Person received the message. So let's say that there is a message going from Alice to Bob. Eve received it, blocked it, kept it, all right, and send it like after 2 weeks. After 2 weeks, all right. So Bob will not be able to verify it because it's just a message. The keys are correct, everything is correct. So for that, what we have to do, we have to include a time stamp. We could include a time stamp, okay? So it could be replayed by the adversary, so this is called timestamp digital signature. Also, there is some other technique called blind signatures. Blind signatures. So for example, think about like the third party, right? Okay, there is like a contract between me and Susan, okay? And I have to use a third party to sign it, right? But why they have to see it? Why they have to see the document, right? So we need to have something called a blinder. So we send a blind document that they could sign it, but they should not be able to see it. Okay? Another example, let's say that I need to notarize a patent, a document which is a patent. So I go to a notary public, to the bank, whatever, okay, I need to notarize it. Why they should be able to see it, right? I mean, I need them to, yes, to notarize my signature, but they should not read the document, right? So we have to find a way to make it like a blind notarization, or in this case, blind digital signature. So sometimes we have a document that we want to get signed without revealing the contents of the document to the signer. All right. So there is different techniques for that. Unfortunately, this book, alluded to them. Okay, but did not, explain much about, how to do it. So David Schoen has developed some patented blind digital signature schemes for this purpose. The main idea is as follows. Bob creates a message and blinds it, but sends the blinded message to Alice. We'll send the blinded message to Alice. Alice signs the blinded message and returns the signature on the blinded message. Bob unblinds the signature to obtain a signature on the original message. So it seems like there is a different techniques to do it, but it's good to So the major applications for using this thing is later on to have certificates, right? So we have something called certificate authorities, CAs, certificate authorities, which was developed, a while ago. The certificates must be signed by the certificate authority. So this certificate is signed by the certificate authority to be valid. Digital signatures are used to provide such proof. When Alice needs to use Bob's public key, such user, she uses the certificate issues. By the way, that's how the programs are installed in our computers, like from the server. Like when you use all these programs out, how these programs, for example, we have like thousands of workstations connected to the main server. All right. So how the server or how the workstation know is an authentic application to run using its certificates. So there is a communication between the server and the workstation, all right, to prove any application can run through certificates. So a lot of things happening within the network, we don't know about it, happening between the server and the client uses certificates. All right? Certificates. All right? Right? Many applications, many plugins you download to your Google Chrome, to all of them, right? So it will work, it has to be verified. This application, how downloaded, it has to be certified, it has certificates, right? So this certificate needs to be signed. Signed by what? By digital signature. By digital signature. Not your digital signature, that's a different story. Digital signature, this is like for communication, but this is, you know, for authentication between the servers and the clients, right? So it's a very common and very, very useful and very used, you know, to secure our systems. So, ladies and gents, this is the story of digital signature, all right? It's a very useful. Okay, next week we're going to talk about entity authentication. So entity authentication, which works hand to hand with the digital signature. What is entity authentication? What we're going to authenticate? Users to servers, servers to workstation, and to clients. Okay. There's different techniques to do that, like using passwords, one-time password, challenge and response. Many different techniques that could be used. So that's what we call it, entity authentication. Different techniques we can, biometrics nowadays, biometrics, right? Different biometrics, these all called entity authentication. Then we come to a very important topic, which is we're talking about keys, right? Public keys, private keys, all of these keys. Where do these keys come from? I mean, I know, like, maybe in my life, like 1,000 people I'm communicating with them every year. All right, how can I have these keys, right? All right. Forget about you and me. I mean, like, you know, the workstations or the server communicate, for example, with thousands of workstations, clients, computer clients. There's keys and certifications involved. So we have to have something called key management. Key management. Where's my keys? Key management, right? So my simple key management, you know, for my keys in here, I put them in a ring like this. Right? If I didn't have the ring, then I have like pieces everywhere. All right. The same thing. These keys will create rings, virtual rings for the keys. Public keys, private keys. We'll talk about this also for, you know, to the management keys, right? Kerberos. Anybody hear about Kerberos? You know, this is how, you know, computers authenticate to and users authenticate to each other. Okay. After that, we'll continue. I mean, we are almost there. All right. And then after that, we'll talk about security in the three major layers. We'll talk about network. We'll talk about the layers in the network layer, in the transport layer, and in the application layer. And then we conclude this part of the course. Thank you so much. So that's fine. Okay, so part of the work that you have to do this semester is to do the research work. Okay? Term paper, research work, whatever you call it. Alright. Alright, so before we start, okay, I would like to ask you, what is research? Investigation. Learning.
Studying
Okay. All right. So let me start with this. It's a philosophical discussion. All right. So I'll tell you my views, You don't like it, flush it, alright? Because it's like an opinion of you. Okay, you could have a different one. So I know some of you have some opinion, some of you don't have any opinion, especially like students who are undergrad, never done research and all that. Alright? So that's the deal. Alright, so again, let me ask the question again. Alright, and this has to be interactive. We're gonna have fun for 1 hour. By the way, did you watch the video I told you to watch?
Yes.
Okay. Was it interesting? Scary, maybe. Alright. Maybe that we'll discuss it when we start talking about, when we finish this book, we'll start with the other one. So go back to research. What is research? Scientific research. So when I ask some people, people think okay, to invent. So many people, some students, they say to invent something. I think that's a wrong definition for research. Research, scientific research, in my opinion, is a scientific contribution. It could be as small as this, or it could be as big as like inventing something. Alright? So research is different than search. People also mix between search and research. Search is literature survey, kind of literature survey. So before you start doing your work, the first step you have to do, you have to search the topic, and you have to search what others have done in that topic. This could, by the way, last few years. Do you know what is the average PhD years in the United States, engineering? Let me give you 3 numbers. 1 year, 3 years, 7 years. 7 years. Okay, 7 years is the average. So you have to do a very good search or literature review before you start working for 2 reasons. What are the 2 reasons? Number 1, we'd like to know what every other one done about the topic. You learn from them, right? So people like, working in a certain, for example, there is a glitch in RSA, just making up something. And some people doing some research on that, okay? Wouldn't you like to know what others have done? Right? You'll learn from it, right? Number 2 was the second reason you have to do that. You don't want to work 7 years in a topic and you discover before you defense that it was done 3 or 4 years ago. Somebody already, fixed this problem or contribute, or at least provided the same contribution like what you are presenting. All right? So it's a very good to start with a very good literature survey that involves multiple sources for the problem in hand which you are trying to solve, and it will be preferable that if you could create your own paper or journal paper in the literature survey. Okay? This is the first thing that you have to do. Alright? When you look at any paper, any few read papers, scientific papers before? Many, right? Okay. So how it looks? Fun? Far from fun. It's terse, succinct. Okay, there is no extra word there, not a lot of background, and it's designed for who? The people of the field. I am, for example, from computer science, computer engineering, right? I'm an engineer, right? Give me a paper right now, for example, about image processing. I will not understand maybe 70% of it. It's not my field. So these papers are very detailed into one area. So you have to have the prior knowledge to be able to understand it. Sometimes you end up reading 5, 6, 7, 8, 9 papers, plus 2, 3, 4 books to understand one paper, if you don't have the background. Alright? So definitely when you hold a paper, journal paper or conference paper is not fun. I'm telling you, it's not fun. Alright? It's a challenge. Alright? Whenever the author would like to explain something for you, what is the easy thing for them to do?
Understand.
Huh? What? What is the easy thing for them to do?
To understand, to make the concepts understand.
No, you know what they do? They put like a box, you put the number inside it for the reference. Okay? And at the bottom of the page, you go number 4, 4 is a reference, another paper. Go read another 9 paper, you understand what he's talking about, half a line there. Alright? You finish this, okay, you read, oh, another box. Okay, go, alright? So, it's not fun. It's not fun. Alright? It's not fun, but it's an enjoyment at the same time, if that's what you want to do. Alright? Alright, so that's what it is. Alright. Now, let's talk about the sections of any research paper. What are the sections there? What do you see in the sections?
Abstract.
What's before abstract? Title. To me, the title is a section. You know why? Because most of the scientific papers, the title is 2 lines. 2 lines. Alright? And each line, each word in the line has a meaning. Why is it so long? Why the titles are so long? Because it's a very detailed work in a very sub topic. Okay, if somebody in this class write a paper called network security, what should we do with him? Where would he like to be executed? There is no paper called network security. It's so general title, right? So the title is like explains as much a very detailed explanation for. Okay, then after that what we have? The abstract. Abstract is always abstruse. You know, it just tells you a little bit that could guide you that what is the paper all about, right? Usually like 5 lines, 10 lines, half a page at most, right? Then after that what we'll have? Introduction. Okay, introduction. Above the introduction usually we have a keywords, okay? That, you know, to me is not very useful. Okay, but you have a keywords that you're trying to and then the introduction. Introduction, how you think the introduction is introducing you to the topic? Very quickly, because you presume that you are coming from this field, you understand, just introduce you, you know, directly what they're gonna do. Little bit background, it's not like, you know, it's like 2 pages, 3 pages at most, half a page sometimes, right? Okay, then after the introduction, what you have? Background or literature survey. To me, this is the most important section to do and the least read in the paper. It's more important section because you have read all these papers and you know what you're gonna do. But you know, people not interested in the literature survey, usually interested in what you're gonna do. Then the next section will have what?
Results.
That's the last one. But before that, your technique, the problem statement, right? And problem statement and what's your mechanism. What's your mechanism to do it, all right? What you did, the analysis, the equations, blah, 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 the simulation, all of that. Then what we have? The results. Then after that, discussion for the results, right? Okay. What is the best discussion you could have? What is the discussion that you almost have it in every paper?
Implementation of the
What?
implementation.
This is not a result. Implementation is before the results. You implement your solution for the problem, you get results. Then you analyze the results. Okay, what is the best analysis you could do for the results? Sorry, I could talk and tell you right away. I didn't just I make it like answering question. I'm not testing you, but I think just I need you to think a little bit.
Next steps, research, next steps.
That's the last thing. But before that, what you do?
Case studies.
You had an idea. You picked it up from somewhere. You come with a solution. Come up with a solution. Implementation of results. So how are you going to tell people that your results is good?
Test cases?
Evaluation.
You compare it. The comparison. Okay, so the comparison is a very important, and that's what brings me to the very first point. Okay, you're not expected to be the White brothers and the Addison and Mary, or Dr. Abusnet, for example. All right, you're not expected to be, all of the expected that you have to pick up a research at its infancy or advanced, and you contribute. All right, you have contribution. And then what do you do with this contribution? You hide it? You hide it for yourself? No, you do two things. Okay, if you are a businessman and you have money and you think you're confident, what do? You patent it, right? And publish it. Or you go directly for publications. So this your work, this contribution will go where? To the journal, to the conference paper, published. What will happen? Another person will pick it up, work a little bit on it, have another publication. Everything will go to the next people. And that's how the science advances in the whole world. The science nowadays is not a contribution of one person, or one group, or one country. Although there's major countries in the world not producing more than the others, okay? But it's a production of everyone and shared almost by everyone. And if it's patented, it's patented, right? And of course, there's a private research, that governments do and all of that. But here we're talking about academia here. We talk about us as an academic institution, or academicians, or students in academia. They try to do some research. So you do it, you go and you publish it and move on. By the way, do you know what does it take you to get a PhD in here in this university?
Research.
Two journal papers. And the average length of the journal paper is like 9 pages. So 20 pages will give you a PhD. As simple as this. The only problem to be able to produce these journals is going to take you 7, 5, 3, 5, 6 years, Depends how lucky you are in the area, how lucky in the topic, how successful you to get results. How good is your advisor, to be honest with you. How cooperative, it's how easy you are able to publish. There's different factors, all right? So that tells you that if you have to have in 7 years 2 journals, that each journal will worth work of 3.5 years. That kind of value, that's what the kind of value for this work. I know most of you don't understand the value of time, you understand the value of money. So if this person did not do the PhD, he worked in the industry as a programmer, made $100,000, this worth how much? $350,000. I'm exaggerating a little bit, but that's fine, allow me, only today. Alright? So research is a very important, very expensive, very time consuming, okay, it needs a lot of work. So of course, in this course, I don't expect, although in every cybersecurity network security course, 1 or 2 groups were able to publish. But it's not, I need to do a good job. If you are able to publish, it's a very good thing to do, and it's doable. I always tell the students, and those students here, they took classes with me before. All right, you could take a course. I hate when students, worry about their grades, or who cares about the grades? Grades does not do anything for you, in my opinion. Okay, they come if you achieve the main goal. What is the main goal? Be knowledgeable. You become knowledgeable. All right. If you become knowledgeable, you get the grade. You get everything. So let's say that all of you get A in this class. Is it a good thing or a bad thing?
Depends.
It's good.
Depends.
The best.
Depends.
Depends on
How you do it.
what you did. Exactly. That's what I love you in the first line. You give me good answers all the time. All right. It depends. So you could get A. I mean, when you go for a job or whatever interview, you have A. Okay, for me, when I see it, does not impress me at all, because it could be an easy course, you got A. It could be the professor's idiot professor gives A to everybody, you got A. It could be that you are in a weaker class and you are the best among all the idiots in the class, you got A. It could be anything, okay? Or it could be you are great, yes, it could be you are great, right? Okay, but what tells the people that you took this class and you're really very good at it? You were able to publish. Write a paper, scientific research, publish it. Why? Because it's not evaluated by me, by one person. Okay? There is no, what they call it, grade inflation or what they call it, curve. Okay? It's going to go to peer reviewers. 3 or 4, 2 to 4 people review your paper, and because it's good, and because only it's good, it will be published. Mind you, of course, there is different levels of conferences and journals. So there is something called this could range from 0.0 to 10 impact factors, right? So, and not the same thing, the conferences, there's acceptance rate. And there's different things. But that's what you need to do. My advice for you is don't finish, don't have your degree before you publish 1 or 2 papers. In this course or any other course. And here is a general advice for you. At least in your senior project, make sure you do a very good job that you could publish something. Add something to your CV. Getting A in this course, you cannot lie. You are not going to add any line or other course you take this semester. You are not going to write in your CV, I got A in network security. You don't write this in CV. But if you have published, where you're going to have it, this paper will have 1 entry to your CV, never exits. Right? You have a lot of publications. Right? And these accumulated. You add them, okay? So be careful. Okay. So we'll go to other thing before I go to the website and hear the topic. Okay, let's say that this is your time. Okay, this time. And this is your knowledge in a topic that you doing like research knowledge, right? Knowledge. So what do you think the curve will look like? Like this? No? Oh. Look like this? Most likely like this, right? But at the beginning you learn very slow, okay, in time. So for example, let's say that you picked 50 papers. The first paper takes you forever to understand it. The second paper, okay, the number 45 paper, 75 of the paper you already know, right? So it become anything you read in the field is like sends you up, shoots you up faster, right? So the most boring time is here. The most difficult time in here. All right? You need a lot of caffeine, a lot of hours. You need to send your wife on vacation if you're married like me. You need to do different things. You need to do, children with them somewhere far. Whatever. You need to do something, right? Okay, to pass this time. How about if we talk about knowledge, confusion? What's the care of your confusion about that topic?
The same way, but other
Like this? Like this? So you will be confused very much, and the confusion go. All right. Who agrees with this curve? You agree? You agree? You agree? You agree? Huh? Like this?
The sales function.
Like this?
Yep.
You sure?
That's all right.
Okay. That's how you are confused, right? Well, myself, my theory, again, is philosophical. For me, I draw it like this. All right? So at the beginning, you have no confusion.
Because you don't
You don't know
understand.
anything about the topic. Pick the best paper. Give it to your grandmother. as a gift, wrap it for her, give it to her, all of that. How much she's confused about it? Zero. She'll put it in the garbage. Right? And seriously, that's what happened with you. I mean, like you start, for example, let's say you start reading about, pick a topic, like for example, like routing technique, you know, in a wireless sensor network, right? So when you start reading, it's just a routing. We know routing, we know what's working. So it's, the more you read, another term, another expression come to you. You get confused. You have to learn about it. Then more. The more you go deep in the topic, the more thing you discover. It's like a hole of worms come up, will get you more confused, require from you to read more and learn more. And you know, first night you go a little bit confused, the 10th night he goes completely confused, okay? And you're thinking that to drop out from the whole project and all of that. This is a very tough time because every time we get, because you're doing like a significant research. Every day you learn something new. And learning something new invokes more stuff, all right? And then after that, you know, this curve, in my opinion, never goes like this. You will always be somehow confused. Nobody like knows the whole knowledge. Nobody seals the whole knowledge and all of that. So again, once you pass this stage, you'll enjoy everything. You're about to reap something, all right? So you have to be, it needs perseverance, it needs patience, okay? It needs family support, it needs, you know, it's, okay? All right, so it's, you know, if it's a big research and all of that, okay? All right, so that's what you need to do in this course. All right, so, you know, you have to start from somewhere. I hope that you, in this course now, in your research, you start from here, because you're somehow knowledgeable. All right, my way always, I mean, it's very easy for me to pick topics for you, so you will, you know, or 2 or 3 topics, pick one of them, or all of you pick and do your research. I don't like to do that. Number 1, I know some of you have interests more than the others. Number 2, while covering this topic, I'm sure that you got attached to one of the areas more than the others, or it maybe you worked before, you know, part of research that related to security that you would like to continue. So a person, for example, works in clouds, maybe would be interested in cloud security. Somebody interested in IoT, security, the big data security. People like math, math, you know, mathematicians, they like encryptions and all of that. People like system, maybe they need to look about authentication, authorization, all of that. You're gonna pick your own topic. One advice, that you never go and start picking papers from 1972. Always you start looking at the last 2 years' publications, all right? You glance through them if you don't have a topic in your mind that interests you, and you start reading the abstract, you see how the idea is attracting you. And then after that you have to focus your multiple readings in the same area, to understand what is the problem. All right? Any problem now, you'll find like many papers published recently in that problem. So you need to understand what is the problem you're trying to solve and how the different people have solved it. All right? Usually I draw to my students like this. Okay? So the first thing you have to come with a problem statement, right? The question is, if you have a publication, okay, so usually I use like, you know, let's say that, you know, you have a problem statement, okay, and let's say that you were able to create like 10 papers solving that problem. And each paper at the end, what they provide you with? Solution to that problem. You agree? Solution. So let's say that we have solution 1, solution 2, solution 3, solution 10. Right? Right? Alright, so I usually I look at the solution like a human. What do human have? Genes. What the genes have? Chromosomes. What kind of chromosomes we have? X and Y, right? So I'll give it like a chromosome Y and X. Okay, Y and X, right? Same thing. Okay, Y and X. Y and X. Y and X, right? Right? Oops. So what is the Y? Is the actual solution to the problem, the mechanism to solve the problem. What is Y? What is X? The loopholes that it created. So sometimes when you try to solve a problem, okay, you sacrifice something or overlook something. Loopholes, right? I mean, if this was 0, do you need to have solution 2, solution 3, solution 10? We don't. Alright? So remember that in your solution, there's like parameters that you're gonna make them constant. You try to solve one thing, but you cannot solve everything, right? Okay? So you're gonna have your own solution, and you're gonna have loopholes, problems, still in your solution. Maybe it's still existing, or you have it created. Your solution has created that. Because last semester, I think somebody asked me why I switched them. Usually they say X, Y, right? Not Y, X. Why I switched them? Anybody knows? No, because X is usually the gene for male. And since I'm calling it a problem, I would like to be the problem all the time. XY, right? So I don't want to say Y is a problem, and then somebody tell me why, So let me be the problem. I'm taking it, okay? All right, just a joke. It's a joke, okay? All right. So that's what it is. So when you pick like 10 papers, that's what it is. That's how you summarize it. You're gonna summarize. You assume that. Let's say that you picked 50 papers. Okay, 40 does not belong to this problem. Put them aside. You remain with 10 papers, right? So when you summarize them, you read them, you have to be able to know what is the technique we have used to solve this problem. And you have to analyze it to see where is the strength and the deficiency. Then you read this, the next one, all right? What is the technique and what's the deficiency? To the end, all right? What is the nice outcome of this? A survey paper. You could write a survey paper, all right, where you compare the different techniques to solve this problem. Then, do you think after reading like such amount of papers and knowledge, you will not come up with an idea, your own idea? Maybe you will come with 1 or 2 or 3 ideas to solve the problem in hand. All right? And this is what we call it your hypothesis. Hypothesis of solution, hypothesis. Everyone has the right to come up with his own hypothesis. I'll give you my hypothesis right now. I have a hypothesis. I hope you agree with me. My hypothesis said, by the way, the cars, what kind of tires they have. Now, I have a hypothesis, this is wrong. It should be like this. All the tires should be like this. Do I have the right to propose this hypothesis? Yes.
Yes.
As long as you are not killing people or animals or doing something bad, you have the right to do whatever. But also you have a right to ask me what? Prove it. All right? I have a right to have any hypothesis. cannot shoot me for any hypothesis they have. And you have the right to ask me, prove it, right? So ask me now, prove it.
Prove it.
Prove it. I can't. All right. So to prove it, okay, there is 3 ways. That's the research. So how we prove our work? 3 ways. Anybody knows the first one? Mathematically. So I could go now to the equations of a friction, force, whatever it is, and calculate it for this and calculate it and do the comparison until you hit. There you go. Mathematically, these tires will save in gas, will save in friction, will give you a very good performance, and I could prove it to you mathematically. And that's where you start usually if you can have mathematical model for your problem in hand. What's the second way?
Experience.
Practical.
What's practical?
Physical.
What? Physical?
Prototype.
What?
Prototype.
Prototype, which is simulation. So there's so many simulation packages. Pro, E, Cam, CAD, whatever, I don't know what is related to this. Okay? So simulation. So you go to all of this, you simulate a car with this kind of tires and car with this kind of tires, and you get the graphs, the graphs, the comparison, the comparison, and you present it in a paper. Here I go. This is the proof that, with the simulation, that cars with the triangle tires, perfect, like this. Okay, what's the third way? Read a prototype or design. Like we built 2 cars, one with, we don't have to build this car, it's already available, too many. We built a car with this one, just take a ride, speed 70, Hopefully that will survive the test, the test and all of that. Okay, maybe you'll be surprised, right? We'll be surprised, right? We'll take a ride for this, and we'll give the prototype. Maybe we'll invite President Trump to try it. I mean, he was just chatting with people, looking in the space, right? Did you see it? All right, so there's people in the space. Maybe we'll invite somebody good to try it. All right, all right. So, and we'll tell you, okay, if it's like, bigly acceptable, okay, so it's good, right? All right? So that's what you need to do. For your work, what are you gonna do? You're gonna come up with a problem statement of your own, all right? Then you're gonna do a nutrition survey. Then you try mathematically. You can prove your solution mathematically. If you can't, by simulation. All right. I mean, the best if you try the 3 of them, impossible within a month or 2 to do that. Okay. And try your best. The idea here, I needed to delve deep. I mean, so far what we were telling you in the class, what has happened? The story. Okay, basic science. This is kind of applied science, right? So finally, before we leave, what is your sources for information? Okay, so all of you, like you are part of UB. So if you go to the library, you have access, of course. You have access to where?
The display is
It's
Lights,
not working,
Explore,
this display.
whatever. Okay, so let me.
The auto timer.
So it seems like it turned off and it has to cool down before you start starting. Okay. So, if you go to the library, there is like, you know, the subscriptions. University have subscriptions to IEEE, it has subscription to ACM, I think, different scientific, you know, journals. Also, the bigger pool for all of this where in Google Scholar. If you go to Google Scholar, and there is a mechanism that you could search for a certain. So let's say that cloud computing, security in the cloud, is something interesting. So you could write few keywords and try to pick, you know, many papers. I mean, I want to show it to you. So just a second. What? You have to submit the paper? Yes. So what you need to do, number one, you need to form groups. You could have a groups of one person, two person, three persons, or so somebody like says, I would like to work by myself. That's fine. Okay, you could have a groups of 2, 3 people. That's fine. Up to 4, I have no problem. All right. So I'm expecting that, like, you know, minimum like 2 to 3 papers per group to be read and summarized and in nutrition survey, and then you're gonna come up with a problem statement, and from the problem statement you're gonna work together to implement your ideas and solving the problem, right? Then you're gonna try to write your paper. You're gonna present to the class. So after like 2 weeks from now, my plan is to finish the class in 2 classes. We're gonna have 2 more classes to teach. Then we're gonna have the exam. We're not going to wait until then. Then I'm gonna switch to other book. But meanwhile, we're gonna have few presentations for you. Okay, so in 2 weeks, maybe you'll have the first presentation, or 3 weeks, and you know, we'll work together. It's, we'll try to. So in here, for example, in here, this is like, I mean, this you can get all of that. So this is like IEEE Explore, is the digital library for IEEE. So what topic you would like to talk about? Let's search for something. Pick one.
Prime numbers.
Prime numbers. That would be scary. So as you see in here, there is about 2,300. Okay, so conferences. There's about 1,500 conferences. We talk about prime numbers. Journals about 800. Courses 300. Books 5, and all of that. So when you go down in here, you will find, you know. So I mean, of course, you are not going to go through the 2,000 or 3,000 papers, right? So that's why when you do search, you have to be very specific for what you want to do. Very specific for the search, right? And let's say that will get you, let's say, selection of a parameter R in RC5 algorithm on the basis of a prime number. It seems like, you know, this is like from 2014. It's a conference paper. If you're gonna look for something really substantial, look for a journal. Usually, like every 2 or 3 conferences equal to a journal. Usually, even in the PhD, what you do, you have an idea, early idea, you publish a conference. More results, you publish another conference. You put everything together, it becomes a journal. So, you know, depends what you want to do, right? So when you look at this and here, you click it in here, and it will give you the abstract. Okay, that's the abstract. So from the abstract, you will know it's useful for your topic or not. I think the keywords is not very useful. Maybe it's useful, but I think the abstract is the minimum that you have to need before you filter it in or filter it out. Let's read. You read. You pick it. You can see. You can see. Okay. Okay. With the utmost application of wireless network and internet has actuated substantial demands for information security and data concealment. However, wireless systems are more susceptible to illegitimate access and eavesdropping. RC5 is what? Is one of the hashing techniques we spoke about last week, right? Alright? Has a variable parameters of word size, length of secret key, and number of rounds. Roland Rivest suggests that RC5 algorithm with 12 numbers of rounds for their encryption. In this paper, here you go, here's the business. In this paper, the proposed work is that if the value for the rounds in RC5 be a prime number, then the security level of the cyber is more. And compared to the higher value of the rounds up to next prime number by the National Institute of Standards and Technology, NIST, suite. Different tests of RC5 algorithm are performed have same data length and key but for different number of rounds, and the result for prime number of rounds is equated with composite number of rounds, and results obtained justify that RC5 for prime number. So we're talking about the importance of how big are not prime number and rounds and RC5, and that's what you're gonna have experimentation in here. Alright, so if that's what you work, like probably how to foster RC5, which I will not pick this topic because RC5 now becoming part of the history. It's not secure, it's found not secure. And I'm not sure why somebody, you have to be wise what you pick, the topic you pick. You have to see how important, but let's say, you decided to work in that, right? So in here, you could download the paper. I'm not sure, here. And you go over it, okay? So it has, remember that when we said the title is like a section for me. So selection of parameter R in RC5. Parameter R, what's parameter R? Right. It's one of the parameters in designing RC5. So, seriously, if you give this to my dad, read it, how much you gonna understand from this title? And he's a PhD, by the way, but not an engineer. No. So these papers are meant for the people in the field. Actually, give this title for you before you take this class. How much you will understand? Will you know what's RC5, for example? What's R? Huh? Yeah. Good if you know prime number. That's good. All right. So then you have the abstract. If you read the abstract, it's like usually like abstract in keywords. Then you have introduction, as you see, like one page. And you have the structure and the description of RC5. Alright, there is equations in here. Just check. So this is the rounds in the plot diagram of one round of RC5. Alright, and the guy what he did simulation. He simulated it with multiple rounds, maybe and different times. And you see the graph in here. This is the results in here. It says bar graph comparison between the average value of NIST suite results for RC5. Right. And this figure says bar graph comparison. So he compared it with like the standard and see how improvement will happen. Alright. So simple. How many pages? 5 pages, 6 pages, but there is an idea, there is a simulation, there is understanding to the problem, okay? In this paper, before you work, so you have to understand the structure of RC5, right? You have to understand. Then you have to understand, what this guy is coming from, what is he trying to improve. Then, how he implemented that. Then, how he compared it with the previous work. Then yourself, for example, you're gonna come up with an idea. He did, multiple rounds, let's say the prime, whatever, composite number. You start thinking, you're an engineer, you have a brain, right? You have enough knowledge to analyze, right? People look at things differently, try to comprehend things differently. So you might care, they always say, like, 4 eyes better than 2, right? You agree? Right? He has 4 eyes, right? you have fries right now. I need fries, to be honest with you. Too lazy to make one. All right. So so that's what it is. That's why working in group is a very important. Working like a team. Like you read this, explain. So let's say you have a group of 3 people. You read. I mean, you pick 3 papers. Everybody will read the paper, and then over a coffee you explain. Okay, my turn. And then this paper talks about this and this, and you start explaining for your colleague. You make sure they understand it. Then you give the mic to your colleague. So in 1 hour setting, you could learn about 3 papers, understand them very well, because one you work on it yourself, and the other 2 your colleagues explain it for you. All right? What is the best way, by the way, to learn anything?
Teach.
Argue?
Read.
I think, yeah.
Teach.
I think the best way to learn anything is to teach it. All right? Seriously, I mean, it's like, I mean, standing in front of you, by the way, it's not easy. Because, you know, anyone, if they want to challenge me with any question, it's easy. Okay, the amount of knowledge all of us know is, is little. All right? So, I mean, you know, we spend like 4 or 5 hours preparing for our classes, but how much we learn in 4 or 5 hours? All right? So, teaching is not easy. Teaching, because when you teach, you try to understand everything. And you don't understand from this textbook, get to other textbook. You know, because you have to stand in front of people. You have to explain to them, right? Same thing. When you try to teach your colleagues, okay, you'll feel the heat inside you. Yeah, I mean, my God, I don't want to waste the time of my colleagues. I have to explain to them very well. And if there is something you cannot understand it, then you cannot make others understand it. You'll make sure you understand it first, that you can explain it to others. That's how it is, right? So, and that's what is useful to do presentation in the class. So you're gonna have a presentation in the class. We're gonna ask each other a question. We are equal in here. That I tell everybody, I mean, in every class, I'm standing in here teaching not because I know way much than you. No, I was just given this privilege to talk before you and explain things I know to you. But you know, we learn from each other. Okay, that's what it is. All right. So I wish that we always could start with the research earlier, but I don't think you pick up enough information or knowledge, especially if it's the first course in the area, that you could start earlier. So I need you to go through this experience, okay, and try that. So form a groups. Go to Canvas, add yourself to groups. So you could meet after this, you know, form groups. You could be 4 in a group, 3 in a group, 1 in a group. Meet, exchange phone numbers, whatever. Communicate with each other. Okay, meet and pick up the topic, and you know, do your best. Enjoy it. I mean, you have, believe me, by now you have enough knowledge to tackle any paper in the area. You have enough knowledge. You know, about, like, we taught you a lot of math in this class. We taught you a lot about the cryptographic techniques, about many things. So believe me, you know, you know enough to do things. All right. So that's what it is. Also, when you do search, for example, also I forgot to mention that, you know, there's so nice filters anywhere. So in here, for example, my friend here, Cesar, picked prime numbers. So, you know, you could say, for example, no, I'm interested only in journal papers. Just pick journal papers. Okay, you say apply here journal papers, right? What we agreed also, we should not go for paper published many years back. So what you could go, oh, I need to look at the papers in the last 2 years. So you select like this, you know, in here, okay? So you're looking for papers, for example, last year, 2018, 2019. You apply it, for example, let's say 17, no problem, 17, 2 years, right? You apply it, right? So how many journals we have just in the last 2 years? Okay, it's conferences is about 270, and no journals. That's fine. All right. Okay. There is magazine 7 and all of that. So it will narrow it down. With the keywords you pick, with the keyword you put in here, you will be able to narrow it, So you need to do research. I mean, successful opinion, it will give you within 100 papers. 100 papers in the area. And then you go abstract, one after one, try to read and all of that. Then let's say in the middle you like the topic, oh, this is interesting topic, go inside the paper. Okay, you have to love the thing you're gonna do, right? I mean, that's the whole point. I'm asking you to do that. Full training, okay? Number two, I need you to do something you like. It's very easy for me, myself, I could do the homework for you. Could go do, okay, pick this topic, go work. I don't wanna do that. I need you to pick something that you feel it fruitful. I'm sure through the course, like, Cesar picked what? Prime numbers. He loves prime numbers, I'm sure by now. That's what came to his mind. Right? Yourself, you'll pick, something else, right? And work together. Now, 4 groups also gonna meet together and deciding one thing. Any questions for me? Do you think I'm boring today?
No.
Yeah.
So we need to figure out a problem statement, as you said. So we're going to research this and we're going to figure out a problem statement.
You own a problem statement.
Okay.
So usually you're gonna pick like 3, 4, 5. Let's say that you are grouping 6,
Okay.
3 people. You need 6 papers. So these papers, more or less, addressing one problem. Not problem statement.
We need to do any trial
One
and error.
problem, right? Huh?
We need to do any trial and error method also.
Literature survey said.
Like trial and error method, we need to go from one thing with the case studies.
There's nothing called try and error. You're gonna, pick, like you sit together. There's a general idea. You're gonna pick like 5, 6 papers you think is close. So you filter it to 50 papers, for example. No, this is filter out, filter in. Then you're gonna come with the 6. All right, and later on you could filter it more, remove and add, whatever. Okay, but let's say you come up with 6. You're a team of 3. You read 2. You read 2. You read 2. Let's meet this weekend. This week we're gonna cover 1 paper. You read it from A to Z, explain it to us. 3. So by the end of this week, how many papers do you understand them A to Z? 3. Next week, another 3, 6. This will give you enough information to come up with a problem statement. Let's say you are not able to come with a problem statement to solve. Let's start again. 4 rule. Okay? Do it again, pick another 6. Okay? That's how it is. All right? And I'm not asking you for something sophisticated in here. I'm asking something that's worth, our time and we listen to you.
So
Something worth our time to listen to.
it has to be related to network security.
What do you think? I mean, I'll leave it to you to answer this question. So,
Do we have any previous papers which has already been, or something which we can refer, something to in our files section on Canvas or something? Something which has already been done, where we can
done with who?
use.
With me?
Yeah.
Yeah, I have like students who publish. I could share it, but it's in here. Just write Abu Zunaid, you'll find it. Everything is published, right? You don't have to. That's the whole idea.
Okay.
The whole idea is you'll be able to publish. Okay, to be published, and you have your, again, when you are able to publish is 1 entry to your CV, never exits. 1 entry to okay, that's the whole idea. Yeah. And you have to, the idea here, I need you to have the mindset of research. Okay? Research. What is the most important thing for researcher? Critique. You criticize everything. Okay, you believe and disbelieve. Okay? Because this all like, I mean, many times, sometimes you read paper and you look at the results, you feel, it's impossible these results to be true. Something wrong. There is, not correct result. There is, sorry to say it, fake reporting for the result. I mean, you are engineer. You're an engineer, right? Okay. So you have to be critical about everything. Not every idea presented, okay, will give you a solution for the problem in hand. It will give you aspects. So you have to be critical. When you read, it's not like when you read a textbook. When you read textbook, it's kind of already given science. Everybody, So if you pick this network security, or the one for stallings, or the other one for different, it's all the same. This already science is like kind everybody agreed on, just to present it for you in a different format, right? When somebody explains RSA for you, RSA is an algorithm used everywhere. The only difference between this textbook and this textbook is just how they present it to you, how they explain it to you, right? But you know, in these papers, these are research. Not everything there is 100% accurate or correct. Ideas, trial to solve the problem. There's people, most of the people are very honest because it goes through peer reviews, but sometimes you come across like some results, right? You work in machine learning, deep learning, right? And I'm sure that you come across like some of the papers and they look at the results. Nah, can't be, you know. I mean, I don't work in machine learning, deep learning, but I have few of my colleagues, you know, told me, you know, and it goes through the crack, right? So that's what you need to be. You need to have a critical eye, critical thinking, you know, try to solve the problem. So, all right. We'll try the next of the semester. Also, when I give you the exam, I will not give you exam to cover the whole material. I'll try to give you part of it. I don't want you to focus. This is not a promise. But this is what I'm saying. I need you just to give you some time to focus on your research also. Fair? All right. So that's what we're gonna do the rest of the semester. We have material to cover, and the rest of the book is easy, by the way. It's much more easier than the beginning. Now, so we're gonna cover a few easy things remaining, and then you need to do your research paper, do the homework. Okay, you do the homework, you'll do very well in the exams. Okay, and focus on your research paper. That's what I need you to focus on. Yes.
So I want to ask a couple of questions. Then do we have to do any programming?
You have what?
To do any programming project like this?
Programming? That's your code. This is your code. So for example, if you need to prove the concept mathematically, okay, if you need to use a simulation tool like MATLAB, if you need to write your own simulation, okay, using Python, it's your code. I'm not dictating on you, all right? Your work will be judged. It has to make sense. There's a problem statement, literature survey, what you're trying to do, your way of handling it, how you prove it, the results, compare the results, publication. All right? So, I mean, most of your questions that you have in your mind right now will vanish once you read the first 6 papers. When you read them, you'll understand what is research. And that's the whole point, believe me. Any other questions?
Any specific deadline?
Any specific deadline? December 15. That's where the course ends, right? But by the way, I mean, mostly with the students who, to be honest with you, people who were able to publish, they did significant work, and then they requested for incomplete grade, and they worked like a few weeks more, and they were able to publish. So yeah, the time might be tight, but you always can have extension. You know me, I'm the most flexible person in this classroom. Questions? All right, we'll work it out. So like if you have like good idea, good results, and you need more time, be my guest. Okay, I'm here in the break. You could come see me every day. All right, if you would like, you know, just to finish, you want to stay, you want to work further. Whatever makes you happy. All right, whatever makes you happy.
Sorry, do you have any suggestion like research areas that we can?
Research area, anything related to security. So I'll tell you what's hot right now. If you Google trending technologies, okay, I've been doing that every year for the past 5 years myself. It's a good thing to do. So what do you think the trending technology nowadays? IoT, Internet of Things. Okay, so if you do, okay, do you think IoT will fly without security? No. security and privacy is the major. Actually, I was invited to give talk on Monday in Southern State Connecticut University for computer engineering, and I spoke about IoT. All right, and start telling them that everything will be connected to the internet and explain the trend and all of that. There is a person, like big person in the back with a ponytail. I come to know he's a professor in education in that university. And he said, how about my privacy? How about my security and all of that? This is and he's angry. I'm not sure why he's angry. Don't get angry at me. I am not, okay, so I have to cool him down, and he's right. And when I start talking about, like, telemedicine devices, that you could have, you could put everything in your house in IoT, that it could be controlled remotely and all that. Think about this, it goes in a crack, and some people get to, you're an IT guy, so get into the system. So IoT is IoT. How about cloud computing? Security, everything in the cloud. By the way, myself, I have 2 tera in Gmail, and in Google I have 2 tera. Everything that I have in my life, I pay like $10 a month, $11 a month. I have 2 tera. I put everything in the Google Drive. All right. If this account gets hacked, I'll be naked in front of you. Okay. Everything, every contract I have, everything, every tax document, everything.
Why do you choose that?
What?
Why do you choose to do that?
Why I choose that? Because I'm very sick and tired having like 20 flash drives and hard disk drives, and I work in my office in a file, and I forget to back it up. I go work at home, different file. I get sick and tired of that. So everything I have now in a central location. Okay, I access it from here, from any computer. All I have to mount my Gmail account is get privacy and security in a cloud computing. I hope it's secure, and what is the major thing we have learned from this course? We are not secure. Remember when we spoke about the algorithms we used? What did we learn? That these algorithms are public, and the strength coming from where? Hiding the keys. And the keys, why the keys? Can we hide the keys? Of course not. You can. The only problem we have that to calculate the key, it's gonna take 200 years to find it. So let's say tomorrow, for God's sake, that everybody will able to get supercomputer in his house. Just imagine. What security you have? No security. So definitely in a few years, okay, we have to think about different algorithms, much more complex. I don't know, maybe longer keys. Instead of the keys like 512, it will be like, 512,000. I don't know. But I don't know, okay, something has to be done, all right? I don't know. Okay, so IoT security, cloud security, big data security. It's everything now is about data, all right? Project I worked with one of the PhD students is using machine learning for intrusion detection system. What's intrusion detection system? That's every network now have it. Before the router, we have something called intrusion detection system that checks the packet if it's intrusion or real one, is benign or normal. So if it's normal, let it in. If it's like intrusion, filter it out, right? So the basic intrusion detection systems work in 2 ways. Signature based, that there's signatures for packets. If it's a virus, there's signatures. So when you see this signature, filter it out. Or an anomaly, behavior. Okay, behavior, right? Okay. But the problem, the signatures keep changing, and the behavior keep changing, because you could make it a slow behavior that even the system does not detect it. So what is the best way now? To use machine learning, deep learning, to have a smart intrusion detection system. So you don't have to wait for zero attack to happen and then be detected, and the signature list will be updated to be able to detect it. It will be like, machine learning, deep learning, it's like adaptive detection for the signatures, anomaly, and all of that. This project is going on. We work with this There are so many things related. I cannot tell you. Security, privacy everywhere. Normal network, normal algorithms. Okay, algorithms in here. All right. Some people who are like good in math and all of that, they could like have their own testing for this, try to break it, right? To find where's the loopholes, okay, or force it, make it stronger. So I cannot tell you. I mean, I want you to have the freedom. And seriously, after like 10 lectures so far, how many lectures we have? 7, 8, 10 lectures. If you don't have anything stick in your mind that you need to do, I'll be not happy. You know, something I'm sure should be excited about something to try to help out. But IoT will invade every house. It's happening. You'll have everything. These chairs, for example, okay, will be connected to the internet. In the future, the movie theater, there is no employees. Everything, the doors connected with the internet. Everything, the chairs, okay, everything. Okay, so just people go to the front to get the tickets. All cameras everywhere. Okay, then the system will be able to know how many people are sitting in each chair, right? Okay. They need to order popcorn, whatever. It's all will be part of the internet. Everything part of the internet. Your house. It'll be all the doors, all the refrigerators, all the curtains, all the AC, all the heaters. Everything will be connected to your cell phone. IoT, Internet of Things. Okay? Internet of Things, you see? He's shaking, he's not happy. Privacy. Alright? Privacy.
Generally only if you let it, though.
What?
Only if you let it. You still have the choice to put the IoT device in.
Well, right. It's your own choice. I like this. By the way, myself, I was against having cell phones to the children. I believe children should not have cell phones. I still believe that. All right. So my first one, my older one, he had his first cell phone in his high school, first year in high school. He sent me few of his friends as a connection. Could you please give my first cell phone? No. Okay. I was very strong, all right? But the moment he got his cell phone, the other two got his cell phone, all right? The one in elementary school and one in the middle school. So I was strong, okay, strong. And by the way, good phones better than mine at that time, right? I mean, you think like those. I mean, we are so much invaded by technology. So the balance between convenience and privacy. I mean, if you decide to go for convenience, check your child. If you have a son or daughter, okay, good luck. Good luck. I mean, seriously. No, I mean, it's no way. I mean, we have to work in fixing the problem. Okay? The idea that, I should not choose it, many things I never thought I will have it myself. By the way, I am one of the most late people had the cell phone. Myself, all my friends had cell phones. Okay, the first time I had cell phone in 2001, when my wife got lost. She was a student, so I was looking for her. She was looking for me. All that I said, no, now I gotta get the cell phone. I mean, cell phones started in 1997. I never cared about cell phone. Okay, I could live another 10 years. The moment I had the cell phone, what happens? If I leave my house, I forgot my cell phone. I go from here, go back home to get the cell phone and come back. It just becomes part of your system. I mean, you can't, Facebook. I am one of the latest people had Facebook. Okay? And year after, I become addicted. What? Seriously? I mean, people talk about Facebook. What's Facebook? What do you see on Facebook? Whatever. Okay? Then I created my account and became addicted. Seriously? How many hours? WhatsApp, messaging. Okay? I was not addicted so far, but hope will not happen. So, this technology and all of that, it's really, security and privacy and these algorithms and all of you now, you are part of the elite club. We should work on it. We should, think about the, IoT. Now, for example, how is like surgeries in the hospitals, right? Okay. So before anybody does a surgery, it takes like 2-3 days, 4 days. right, in the hospital until he's okay. Nowadays, you could replace a kidney 2 days till you're out. That would save money than insurance, right? Okay. In the future, that they will connect you with this device that measure your blood pressure, your rates, everything, your vital readings and all of that, and automatic reporting to the cloud where the doctor could get the alerts and all of that. For the elder people, for the people having diabetes, heart, okay, that's what will happen. Okay. And when this is happening, and this is what is the norm, you'll not be able to reject it. You're not able to reject it, and it's like part of the system. We are just another stone in this system, seriously. And we're motiled and mobiled, okay, by what's happening in the world system now, right? We are just another number, and we cannot do. I mean, like let's say that in 5 years, the auto-driving cars happen. Auto-driving cars happen, right? Okay. Tell you what, forget about all that. It's a long story, you know. Okay, talk about like now that the connecting the cars to the internet, right? So my wife has Suburban 2017. It has this thing that could connect what they call, I forgot what they call it, Wi-Fi and for service and all of that. They told me $9, but by the time I don't need it. I don't need it. Thank you. All right, $9 is too much for me, right? Okay, because I don't need it to be connected, right? Okay, but now every car you're gonna buy in a few years will have that system. You will be plugged automatically to the internet. How many cars nowadays you buy without GPS? When the car is like GPS is like part of it, and of course with GPS you're tracked everywhere, right? Tracked everywhere, right? Okay, recorded and everything. So, no, the world is becoming scary. You should look in the map and Google, find like a good jungle where you have your retirement. That's what I plan to do. All I need in my retirement: a small house, cow to milk it, milk. All right, and I don't need Wi-Fi. I don't need science. I don't need anything, and books to read. All right. Hopefully, my wife with me, if she bears up. If she can live with me this way, and yeah, scary word. Right. Sorry for the long answer, but seriously, I wish it's simple as you think. All right, I had the experience with my children, and many things I would never imagine I will try it in my house. I have it in my house. Refrigerators. It will be connected. It will be. Oh, a funny thing. This summer I bought like AC. This is true story. AC, window AC, right? And when I came house, actually ordered it using Amazon. She came to the house, and then coming home, and my children jumping to the car. Guess what? They give me the remote of the AC and it has Wi-Fi. Why the remote has Wi-Fi? I don't know. And seriously, why a remote of AC has a Wi-Fi? Why I need to have? I did not even test the internet.
Where you're at?
For the app? Oh, see, I did not even test it.
You turn out the phone.
See? What I'm talking about. Refrigerator, when you have your refrigerator is like, camera and all of that, so you'll be able to check it. And everybody look for the convenience. 15 years, I never believed in something called dishwashers. You know what dishwasher? I never believed. It was so stupid to me. Because before you put things in the dishwasher, my wife trains me. You cannot put the things dirty in the dishwasher. You have just to rinse it a little bit, remove the stuff, then you put it in the dishwasher. I said, if I have to rinse it, let me clean it as a whole, and then you put it in its place. Why I have to, you have to rinse it, spend like 15 minutes rinsing it to put it inside, then it works for 2 hours. 2 hours. You do okay? And then, while you could do the whole business in 15 minutes. I use the dishwasher every day now. Every night, It's actually my job in the house. Nowadays, my formal job. So, please pick the topic you want. I'm sure it's like the hole is too big to patch, okay? It's, you know, the loopholes is too big to patch, and you hear about cyber crimes nowadays in billions of dollars. So I'm sure that you'll have a good contribution, all right? I hope no more questions. Let's go at least one stone early. Thank you so much. Enjoy your night.